These are two real solutions. The last type of question you're going to need to know how to answer is, what do you do when asked to complete the square or solve an equation by completing the square? So now we're going to look at completing the square. Whenever you have equations that are not perfect squares, you can make a perfect square in order to solve. So if we look back here again, you can see that when we made this equation, we had a perfect square. X plus 5 squared, that's our perfect square. Came from a perfect square trinomial. In this case, we are going to work with the fact that we don't have a perfect square trinomial. And our purpose is to make a perfect square trinomial. How can we do that? What goes in this blank right here in order to make a perfect square? Well, I will tell you that every time that value should be b divided by 2 squared. So in this blank, we can write b divided by 2 squared. That will create a perfect square trinomial on this side. However, anytime we add something to one side of an equation, we must add it to the other, so you need to make sure that you add b divided by 2 squared on the right as well. One thing I skipped is how we got from here to here. Sorry about that. So you can see that the first thing I did was subtract c from both sides, because we need to have a blank right here in order to figure out how to make a perfect square on the left-hand side. Okay, whenever we subtract minus c from one side, we have to do it to the other, and so it ended up over here. Let's try a problem with numbers. It will make this make a lot more sense. So here's your example. Solve for x by completing the square. X squared plus 6x minus 2 equals 0. This is not a perfect square trinomial, so we need to first add 2 to both sides. When we do that, we get x squared plus 6x plus blank equals 2, because 0 plus 2 is 2, plus blank. We need to figure out what to put into these two blanks. Well, what I told you in the last one, on the last slide, was that we can always put into this blank b divided by 2 squared. In this case, b equals 6. So if I plug in 6, we would get 6 divided by 2 squared, which equals 3 squared. That equals 9. So into these two blanks right here, I'm going to write 9. This creates a perfect square trinomial on the left. So that means that we can use the perfect square trinomial rule that we learned back in Unit 5 to rewrite this. So let's look at what we do. X squared plus 6x plus 9 equals 2 plus 9. This is, we've got a equals x and b equals 3. So our perfect square trinomial rule says x plus 3 squared. And on the right, we just add this together, bring it down, so we have 11. Now this looks just like the problem we were solving previously when we were looking at the intersecting lines, or the intersecting graphs. Take the square root of both sides. These cancel, so you get x plus 3 equals plus or minus radical 11. Get x alone by subtracting 3 from both sides. X equals negative 3 plus or minus radical 11. This is your final answer when asked to solve by completing the square. That's it for this lesson. So go ahead and try your homework now and see if you can do each of these types of problems on your own.